Hello, everyone. Welcome to today's LinkedIn Live session, Innovating Across Industries, the future of 3D design with AI driven solutions. I'm your host, Kavita, and I'm thrilled to have you all here. Let me introduce our esteemed speakers. We have Vivek, the engineering head, Tarun, the head of Generative AI Engineering, Today, we'll discuss how AI is reshaping 3D design and its transformative potential across industries like education, healthcare, manufacturing, and retail. Before we dive in, feel free to drop your questions in the chat. We'll try to address them at the end. All right, let's get started. To kick things off, let's discuss the challenges industries face when creating 3D content. It's resource intensive, expensive, and requires specialized skills. Vivek, could you elaborate on these challenges?
Yeah, absolutely, Kavita. So 3D creation, as we know that it's a very, incredibly valuable across the industries. And if you talk about the recent boom in the esports, e-gamings, and 3D content is like booming. But it comes with a very significant challenges, specifically, let's say in the today's modern world education sector, we need more visualization, more experiential learning platforms where the children students can learn the concepts very easily. So these in education, the interactive, the 3D models can make these complex concepts more engaging and easier to understand. But the time, cost, and the technical expertise required to make these things are very difficult, and it is very difficult to implement at scale. And in healthcare, precise 3D models are very crucial for medical training and diagnostic. Yet, access to high quality, affordable solutions, remains limited so far. Then, in manufacturers, the manufacturer often need the 3D prototypes to streamline their product development, and the traditional methods where people using AutoCAD kind of software, these are very costly and very time consuming. uh, yeah, so similarly in the retail sector as well, the vendors can use their products to create the 3D preview, so that it transform the customer experience. And yet many businesses right now are like struggling with the current resources to create these such kind of visuals. So ultimately, while 3D technology has the potential to revolutionize multiple sectors, accessibility remains a key barrier. And lowering the cost and simplifying the creation process will be critical in making 3D content more widely available.
That's fascinating. It's clear that AI has the potential to democratize 3D content creation. Let's now explore how this vision is coming to life. Tarun, could you walk us through the solution your team is developing?
Yeah, sure, Kavita. First of all, thank you for having me here. So so the solution is we would like to start with is first defining the basic components in here. Like first defining the input and outputs, right? How can we best pre-process the input, right? And what kind of inputs that we can take. So for this particular 3D generation, there are certain different types of input that we can take, that includes text, as well as people can directly write, like give me a cube, and on top of that, give me a cylinder or something, or give me a a cylindrical base equipment that's been used in labs, right? So that they can say they give the input in text, or they can give certain images as well. So they can simply click a photo from their phone and give that image, and they want to convert it to the 3D object, right? And they can use it further for educational purpose, for a matter, or any other use case that helps them out, right? So we would be defining first how do we take the input. Like after that, we are exploring at this point, how many different platforms or models, ML models, or generative models that we can use, right? So the thing is, at this point, not a single AI model or would be able to give answers, the best answer for all the inputs, right? So we have to very specific about certain cases, right? Now I'll be sharing more details on that as well. But like the second component in here would be the output, like, and how are we storing that output. So it would be basically the outputs would be in certain file formats that's been already been used in industry, like the GLB formats, OBJ formats that's been used in like many existing softwares such as Unity, Blender, and like many other softwares, right? So these are the two main important parts in here, right? So yeah, apart from that, this third part, like it would be basically we are just taking this, and like we are also creating platform out of this, right? So this platform would be holding this so that the things we have created is reusable, and it would be reusable across multiple platforms, right? Multiple other use cases, right? So it's not just it's been created and it's put on hold or something like that. It would be available to, based on the requirements, right? So a particular maybe a chair, right? That kind of 3D output would be useful in a lab or a classroom as well, right? So that kind of multiple use case kind of problem would be solved with this library or like a platform creation, right? And we would be helping multiple companies with that, right? So yeah, I think that these are the main four components that we will be building as a part of the solution.
Yeah, so additionally, I want to add our platform since will feature the industry specific templates to make the customization easier. So whether it's medical models or the product prototypes or the educational tools, our interface, the interface we design will be user friendly and will not require much of technical expertise. They will be, uh, the users will be uh, quite feel very what say will feel very it's a very easy to use interface actually, and they will create any kind of customization with our existing reusable components by simply typing their requirements, and based on that AI will automatically generate the required models as per their requirement.
That's right.
Amazing. So it's not just about creating 3D models, it's about empowering industries with affordable and accessible tools. Let's dive deeper into the specific industries this will benefit most.
Yeah, so Kavita, the benefits are immense. uh, in education, the interactive demonstrations help students understand the concepts faster. So I remember my over earlier days, like our teachers try to uh, and understand us the concept with their hands only, or maybe some diagrams on the boards. But now we have the opportunity where the teachers can create such content on their own without requiring any special skills. So yeah, so in the education sector, I see a very great potential. Then in healthcare, professionals definitely can train more effectively with the realistic visualization, and there is a quite big challenge in fact in the having some professional skills, creating some content for the professional skills. So for example, let's say if you want to teach someone how to repair a mobile, now without having the equipments, it's very hard for us to teach someone how to repair a mobile, how to repair a circuit board. or how to repair a particular kind of machinery. But if we are able to create such 3D components with a very ease, then it will be easy for the all of the teachers or the trainers to create their interactive contents very easily. And again this the manufacturing thing. So manufacturing also sees a faster prototyping without a need for a very physical model, or even in the retail as well, the customers will be more confident in purchasing particular product if they can interact with their 3D simulations. Yeah, so I feel a very great potential with such technology.
Okay, to summarize, these solutions cut cost, save time, and enhance user engagement across a variety of sectors. Now, let's discuss the research and insights that inform this approach. Tarun, tell us
Yeah,
about the research that guided this solution. What
yeah, sure.
platforms did you evaluate?
Sure. So yeah, we evaluated multiple platforms in here, right? So the platforms, like if we can further categorize them, right? So we evaluated certain ML models directly, generative models, right, and certain SaaS platforms as well, right? So some of them, like already mentioned in here, like the Rodin, Tripo, and Meshi, and then as I mentioned earlier, like every platform has its different use case that we have as a part of our research that we have found out. So if you see, can you please go to the next slide? Yeah. Yeah, so this one, yeah. So if you see, the if we need something like a very textury or clothy kind of like object, 3D object, you can see like the typo results are really better than like we can really see the texture in here, like the input image in here that you can see, right? This is a cloth material, and it has different kind of cloth materials, and the way the tripod did it is really fantastic and really nice to see, like how the shiny material is also presented, right? The silver one and the other ones, right? So in the cotton as well, right? So it was able to detect it very nicely. Yeah, so similarly the other model, which is Rodin, is like we see results in here, like where the flat surfaces, kind of lab equipments are like really well presented. So it's, you see the input images, right? And the output, like it produces a really great, it does a really great job in like creating 3D outputs for these, right? So if you can see, like it's very shiny and like output, giving output. So Rodin is in a way it's giving good results for this one. And nonetheless, there is another model which is Meshi.ai, right? So even with, we found out even with low quality images, this is able to extrapolate things and like give better 3D objects, right? So yeah, we kind of categorize in this direction, and based on these results and research, we are trying to create a platform where the user can input their add their input, and we detect like what kind of best solutions that can be used in there, and like finally the best 3D outputs that can be done for that.
Okay. And what about rendering frameworks?
Yeah. So there are rendering frameworks, like yeah, definitely this is a good question. Like once we get these 3D objects, and we have to render these as well in the sum. So there are so many existing softwares that we already have, right? So as I already mentioned, Unity, Blender, right? And like there is another JavaScript based framework, 3JS, that we are also trying at this point, and like it's giving good results in terms of like flexibility for developing applications over web, right, easily. And like it can scale as well, like we can create like website out of that, and like share with anyone, right? So it's really great uh, to see that outputs.
Thanks for sharing those insights. Now let's
Sure.
talk about the implementation plan. Vivek, what does the implementation journey look like?
Yeah, so first of all, we are now collaborating with some leading platforms for AI driven 3D generation. So while leveraging these like 3JS for stitching the 3D components. And by integrating these technologies, we aim to provide a seamless workflow for creating, customizing, and deploying the 3D content across various industries. So the platform will feature a diverse range of industry-specific templates tailored to sectors like education, retail, healthcare, manufacturing. And these pre-built templates will help users to generate 3D models quickly without requiring, the deep expertise. So yeah, a key focus for our development is the usability. Our goal is to design an intuitive and user-friendly interface that allows non-technical user to effortlessly create, modify, and implement 3D assets. Now, so we have a development platform where we will be integrating multiple solutions, like multiple third-party APIs or multiple ML models. These are integrated into one black box, and end user need not have to take care about what technology they have to get skills on. So they just required to have user input. And our current development is like, first we are trying to identify the different types of 3D generation models. Then we are looking for these like how where these models can be rendered, can be stitched. And then finally we are targeting the various industries where these use cases can be directly applied. So for an end user journey, it should be just simply like, they will just see various kinds of 3D templates under different categories, for example education, healthcare, or retail, or manufacturing. Then they choose a particular object. They choose their the requirement, like in the as a prompt only. And behind the scene, we will decide which tool for we should use to customize that template using the 3D development platform like mesh AI, everything. And finally we render the everything using the 3JS. So through a streamlined such a platform, we are trying to streamline everything with the no code or the low code approach. And we ensure that the professionals from different fields can harness the power of 3D visualization without requiring any steep learning curve. So yeah, once we have a prototype, we will test it with the real world use case across the industries, like all of these. So feedback will help us refine the scale, the platform.
It's exciting to see a well thought out plan that prioritizes both innovation and usability. Vivek, how does this solution disrupt the market?
Yeah, so as we earlier discussed that the 3D content creation is quite expensive job right now. And we have one client who is spending around several lakhs of you know uh, like several lakh dollars for they're creating a 3D content. So it was very quite complicated. But now, by democratizing these 3D content creation, this platform offers an affordable and scalable alternatives to the traditional methods. It fosters the innovation and efficiency, and empowering the industries to create more faster and at lower cost such kind of content.
Well said, Vivek. This truly has the potential to redefine how industries approach 3D design. And that's a wrap. Vivek, Tarun, thank you for sharing your incredible insights. To everyone who joined us, thank you for being part of this session. Don't forget to follow us for updates. See you next time.
Thank you.